The goal of the big design project is to design, build, and test a machine to score as many points as possible. A team scores points by completing a variety of tasks, including expelling Dementors from the team's home zone, retrieving gems from the center platform while filtering out Nifflers, and imprisoning Grindelwald in Azkaban. The mechanism that the team creates must abide by the competition rules. The team must also consider the opponent's machines and defend against negative impacts they might have on the team's score.
The first design acted as a benchmark for our other designs and was built like the popular class design to represent our view of how we would implement a stationary machine with drawer slides. The machine would start in a compacted position as shown on the right and be able to expand out toward the base to sort through the Nifflers and place Grindelwald by using solenoid pins to hold them in. This sorter expands out at the very beginning of the match and slides up to the middle to begin sorting. The top bar will be used to send the Nifflers to other zones, and the bottom pulls the gems into our zone. The IR sensor on the top sensor when the wall will drop for when Grindelwald to begin extending towards the middle. For placing Grindelwald in Azkaban, this arm extends out with a small string running under the device. Once the string is fully extended, it will pull a pin out of place and release the ball once it is placed over the hole. To expel the Dementor, this design uses a wedge attached to an extendable arm that rotates off of a motor that goes under all the existing slides to push the Dementor into an opponent's zone.
The team's second design concept relies on a cart system that drives down the ramp and positions itself tangent to the rotating center platform. This design has a stationary angled stick and a PVC pipe with a cutout. Once they are collected, Nifflers ride down the pipe into the opponent's zone, while shiny objects fall through to the home zone. In addition, this mechanism protects the home zone against opponent's Nifflers by deploying angled walls to block objects. In order to place Grindelwald in Azkaban, this design uses a scissor arm connected to a pneumatic piston. At the end of this arm, there is a cage that opens as the scissor arm extends in order to drop Grindelwald in Azkaban. In order to remove the Dementor from the home zone, this design features a pendulum stick with motor to hit the Dementor hard enough to expel it into an opponent's zone.
Our first design concept was to use a motor-driven drivetrain to get us close to the rotating platform. We would then use a spring-loaded bar to push all the objects onto a ramp where they would be sorted by size. To place Grindelwald in Azkaban, this design would use a horizontally swinging arm to position the ball over Azkaban and a solenoid to release the ball. The Dementor would then be pushed to the side by a motor-driven swinging arm with a one-way flap in it.
Design number 4 uses gravity-driven sliders with a wooden housing unit attached to the ends to complete the task required in the competition. It features a swinging arm for the Grindelwald task that is activated by a pneumatic piston. The shiny objects and Niffler task is completed using a slot ramp mechanism that pushes shiny objects into the housing unit while sorting out Nifflers. For the Grindelwald task, the robot uses an arm and scoop mechanism attached to the bottom of the housing unit to complete the Dementor task upon egress. The scoop is hinged so that it passes over the Dementor upon approach but does not budge on egress, allowing the Dementor to get picked up by the scoop. In order to egress, a string that is attached to the back of the housing unit will be spooled up using the motor attached to the rear support.
For our selected design, we chose the best components of each initial design and combined them to create a single cohesive concept. To approach and egress from the rotating platform, this design utilizes a motor-driven drivetrain. We decided on this mechanism because although it is somewhat complex, it greatly simplifies many of the other tasks. To collect shiny objects and expel Nifflers, our team decided to use a spring-loaded bar and a ramp with a cutout in it. This mechanism was chosen because it has proven effective and repeatable in early tests and is relatively simple to construct. For imprisoning Grindelwald, our team decided on a vertically rotating arm because of its simplicity and its precision. Lastly, to expel the Dementors, we decided on a static one-way flap that will open when the robot is approaching the platform and stay closed when egressing, allowing us to push the bone into our starting zone. This design was chosen due to its simplicity and its synergy with the drivetrain.
To evaluate the individual and final designs, our team completed 3 evaluation matrices to gather evidence on how each machine performed relative to another team-based design. This matrix uses one design as a benchmark to compare all the other individual designs so that they show the relative strengths and weaknesses. The final design came on top of the most improvements relative to the other designs. The second level matrix builds off the first level and shows how each design is able to handle the customer requirements based on a scale from 0 to 4. This matrix puts each design against itself in regarding to how well it works in relation to a perfect score to show how close to the ideal design it goes. The third level matrix puts the designs against each other and takes the values obtained from the second level matrix and multiplies them by the importance values we created in the House of Quality. The sum of these values are given to each design and compared to the total of all designs. All the designs came out to be very similarly weighted in the end, with the final design edging out the individual ones. This shows that each individual design can complete the given requirements well, but the final design, which is a compilation of the best attributes from each design.
Going forward, the team will build, compile, and test the subsystems as well as the final design. In addition, the team will create spare parts so that repairs can be made quickly and easily. Finally, the entire design process will be documented so that the team keeps track of the steps taken to achieve the final goal.